This is the Porch Pirate deterrent discussion. So these are the three ways that the Bay package can look. This is how it looks when it's on the ground. This is how it looks when the Porch Pirate opens it. And these are the inner workings of the package. If we look at the flow chart, there are really only four states that the box could be in: disarm, arm, standby, and deter. I've highlighted a path down to deter, which is the series of events that would happen when the box knows that it's been stolen. At any point during the code, as you can see, we check the state of the button to see if the button has been pressed. And if it has, we return to disarm state. For example, once you press the button for the first time, it beeps 3 times and arms the system. Then we're reading the sonar sensor distance. And if the box has been picked up, which means that the distance is greater than the threshold of 90 centimeters, then we move on to standby mode. But if it's not picked up, then we check the arm button status. And if it's been pressed, we disarm the system. But if not, we continue this loop. This happens in standby mode, and it happens in deter mode too. Before we go over the code, these are the references that I used. The Christmas light fire starter was not my idea, and I used a bit of the sonar sensor and H-bridge references from the Arduino e-textbook link. Before the code starts, we need to set pins and global variables, as well as include any of the libraries we need to use. These are the pins that correspond to the wiring diagram, which we'll go over later. And these are the code's global variables. Two of these are pulled up, the push button and the limit switch. Of course, every pin needs to know what mode it is, whether it's output or input, and whether it's pulled up or not. The loop is where the code really begins. The first thing the code does is read the distance of the sonar sensor, read the status of the push button, and read the status of the limit switch. This if statement has two parts to it. First, once the button is pressed, if the button was previously disarmed, then it's now being armed. It beeps 3 times and it continues. But if the button is pressed and the system was already armed, then that means it's being disarmed. What happens is the arm, standby, and deter variables get set back to 0. The linear motor retracts, and then it turns off. The state determining logic of the code is probably the most important part. As I said before, when the button is pushed to arm the system, it continues down to this section. If arm equals 1 and the distance is over the exceeded threshold, then that means the box has been picked up, and we're now checking the limit switch. Standby is set to 1, and all we're waiting for is the box to be opened. When standby is 1, arm is 1, and the limit switch is low, because remember it's been pulled up, so that means it's open, then the box knows that it's being stolen and it begins to deter. This is the state in which the box is in when it's in deter mode. What happens is the linear motor extends, but it doesn't retract. The only way to retract it is to press the reset button, which has the code to push current in the backwards direction to retract the motor. The second thing it does is starter pin, set it to high, which sends current through the Christmas light to start the fire. The wiring diagram looks a little bit hectic. The most important parts to look at are the button is connected to pin 2, the buzzer is connected to pin 4. Only half of the 16 pins are connected to the Arduino. Some of them are connected to this 12-volt battery pack, and others are connected to the linear actuator. The sonar sensor is only connected to the power and ground of the breadboard and has 2 pins going to the Arduino. The Christmas light is being powered by the 6-volt pack, which is on the breadboard, and it's going through the transistor so as to reduce the amount of current that's being pulled by the Arduino and only sending high current to the Christmas light. There's a green wire that's connecting ground to ground to make sure that there's a common ground between all the systems. Thank you for listening, and again, stop theft.